Hey guys, welcome to another video. Today we're going to be doing a derivative example that involves the product rule, quotient rule, and the chain rule. That is the hint. So we're going to try to find dy dx, but we need to know what y is, right? So the function y in x that we're given is this. X squared times 2x minus 1 cubed divided by x squared plus 3 to the fourth power. All right, so a couple of things I'm going to note down here is just some rules of differentiation, right? So I'll use the dummy variable t to just write these out. And also a quotient rule. So the reason why I'm using u and v and this product rule is because I have a product between these two functions. I'm going to call these u, this is going to be v, I'll call this one L, right? So, and I'm actually also going to say n equals, we're going to define a new function also, n of t equals u of t dot v of t. And that'll allow us to actually just write this quotient rule. Right? Just replacing the n with what I have let it equal. And that is kind of the structure that we have for our function, right? So we just have to take the derivative of this. And so the quotient rule for n and L equals, what is it? So lower function times the derivative of the higher function in the top, and then we subtract the function in the top and take the derivative of the bottom, and then we're going to divide it by the bottom function squared, right? Now let's replace the ends. So this whole thing is just going to be equal to L of t, the derivative of u of t times v of t, right? And we know that is a product rule. Minus, and then again, we can do u of t times v of t times, and then the derivative of that lower function in the denominator, again, all divided by the denominator squared. Now we basically have our structure. This n over L thing, that's actually just the derivative dt of y, right, of t. And so let's switch back to our variable now that we have our variable x. Now that we have the structure of this thing down, we can actually just write this all in terms of x. So I'm just going to do that right now. Just say y prime of x equals L of x ux dot dv of x dx plus v of x du of x dx, and then minus ux vx dlx with respect to x divided by, if you want to save some time, you could have just done this in the last step. As you can see, I kind of just had to rewrite that entire expression twice just because I didn't put x up where these t's are. So these are the same. Now, this thing right here, though, this tells me what derivatives do I need to take, right? So I'm going to have to take the derivative of v with respect to x, the derivative of u with respect to x, the derivative of L with respect to x. And if I do this here, I'm going to write it in a way that I can look at all the information at the same time. So it might seem tedious to do this, but in a second you'll see it kind of is easier on your eyes. And then, so doing the chain rule, right? So what we're going to do is we're going to take the derivative of this whole expression. We're going to bring the exponent down using the power rule. And we're going to reduce the exponent. And then we have to multiply by the derivative of the inside function, which is just 2. And that simplifies when I bring all the coefficients out front to this expression here. We're also going to need what? du dx, right? So du dx of, and what's du, or what is u of x? U of x we said was x squared. This one is pretty easy. That just equals 2x, no big deal. We also need the derivative of L, right? And what is L? Sorry, I need derivative operators here. This equals the derivative with respect to, I don't know why I put v's here. It should just be the derivative operator, and then this is v, derivative operator, this is u, derivative operator, this is L, and L is x squared plus 3 to the 4th. I want to use brackets because we got double. And so again, we just use the chain rule for this one. I'll bring that exponent out front, reduce it up here, multiply by the derivative of the inside of that function, simplifying. And so great, you can see also that the chain rule allows us to, like a less powerful method would be to expand this fraction and then just use the power rule. Certainly that's computationally like easier for the mental math, but I feel like this looks much cleaner. And I actually tried to work it out by expanding everything, and it just turned into an algebraic mess. We don't have to do any of that. So now that we have these values here, let me do it in a different color. So we have the derivatives of these functions. And that's everything we need to just plug in to the thing. So I'm going to write also, I'm just going to say dv over dx equals that, du dx equals this. This is a v, that's a u, this is an L. Yeah, that way we can see what we're plugging in here. And then I've written the functions here. This is why I wrote it this way. I was very thorough so I can have all the values in the same table, and I don't have to like look around the document and figure out what's what. So if we just plug this in, we will get the expression. And maybe pause the video and try to plug it in yourself, evaluate it. But this is going to be I'm just simply plugging in plug and chug. Very long expression. And I know this doesn't seem like a simplified version, but this is as far as I'm going to go with it. You can choose to simplify this further, but this is the correct math. This is how I would just enter it into the computer program. And so this is our final answer. That is how you find the derivative of this function here. And so I hope this is really helpful. If you enjoyed the video, please like it. Leave a comment if there's anything you want me to clear up, or if there's anything you would like me to cover in the future, and I would be happy to oblige. So thank you for viewing, and I'll see you in the next video.